let's look at parentheses, the different things that they can mean. So if I look at f of x equals 3 times x plus 5, I want to rewrite this and actually show that these are different kinds of parentheses. So this first set of parentheses here are showing me where the argument of the function is. It's telling me what should I be looking for if I want to plug in. So it's telling me x is the variable. That's important because we might have other letters that stand for parameters. We might have different variables in other situations. So my red are the argument of the functions, whereas my blue-green parentheses here are multiplication. This is separating something out and saying, okay, I have 3 times x plus 5. So the red ones say x is the argument of the function. It's f of x. Whereas these others are 3 times x plus 5. So even the way that their head is different, even though they're written with the same symbols. And I won't lie, I mean, this is, if we had it do over again, we might pick a different way to write this to make it clearer. But we're stuck with this notation. No one is going to rewrite their math paper, so you can read it by making this distinction clearer. So we just have to practice with it until we're sufficiently recognizing what the difference is. And these are very, very different things. So if I look at my f of x equals 3x plus 3, if I look at f of x equals 3 times x plus 5, I could look at 4x times, this would be multiplication of 2 functions. And if I wanted to simplify this, I would do 4x times 3 times x plus 5. And because I'm multiplying 3 things together, if I do a times b times c, I only have to multiply the first 2 together or the second 2 together, and there's lots of ways I can rearrange it. So I'm just going to multiply these first 2 things together and get 12x times x plus 5. Are y'all with me on this? To be honest, this is not the kind of math I like teaching. I don't know anybody who gets into math because they really, really think this part's cool. But instead, these are the steps you have to take to get to the cool part. And then if I want to, I can think about, okay, I have a rectangle, which is 12x long, and it's x plus 5 wide. If I can break that up into 2 places, this is 12 times x squared. This is 60x. So I have 12x squared plus 60x. And then I've simplified it pretty cleanly. Any of these are equivalent expressions. So I'm going over the different ways we could try to simplify it. Tell your computer science professors that parentheses are an overloaded operator in mathematics. They'll think that's cool. They know it's true. Now I could also look at something like, what is f of x to the 4th plus 1? Now notice I said what I meant. I said f of. Because here I'm plugging x to the 4th plus 1 in for x, which gives me, I'm replacing everywhere I saw an x in the original function definition with x to the 4th plus 1. And now if I want to, I can simplify this further. It's really important to distinguish that I'm plugging in here versus multiplying here. That's the key insight. So at the end of this, I get 3 times x to the 4th plus 6. I can clean this up to be 3x to the 4th plus 18. But the key is whatever I see inside this argument for these parentheses that represent the argument of a function, you plug in when you see them. The distributive property applies to multiplication. I can do this. I can do 3 times x to the 5th plus 2 is equal to 3x to the 5th plus 6. Because here these parentheses mean multiplication. So this is valid. I can distribute through. The distributive property does not apply to function composition. So if I have something like sine of x squared plus 3, that is not the same. I can't, there's no notion of distributing a sign. It just doesn't work. These are completely different things that don't have anything to do with each other. Are there any questions, thoughts, or comments on anything we've had during this discussion? I will be scanning this and putting it up, so hopefully helpful to you. It's not very exciting.